If you people, you can see over your on your desktop also if the session is getting recorded or not. If by any chance I forget to click this record button, please remind me to record it. So today's session is not recorded. Okay. So over here you can. Okay, this is what I told you right now only. So here's that example of dynamic partitioning. So how to partition your data? I just told you, you can just insert the data to the same table by partitioning it. The similar data, the Hive will create the partitions or the columns for you. Oh, sorry, folders for you. With an example for dynamic partitioning. There was one example of dynamic partitioning. I don't know where that gone. That might be on some other slide. Okay, so let me tell you what is the difference between dynamic and static partitioning. So what I was doing over here is where is that gone? Okay, here it is. Okay, I'll show you the dynamic partitioning. That is on separate slide. So I'll tell you over there. Dynamic partitioning. So that set parameter which I was doing over here was to change that thing only. Dynamic partitioning. So I'll tell you on that slide. Okay. So serialization, deserialization. Now all you understand. You can use those things. So if I have to read a sequence file, all I have to do is just define the input file format which need to be used by Hive and the output file format which need to be used by Hive to read your data. Rest all things will be remain same. So if my data is lying as a sequence file, all I say is create table will remain same. All I say is stored as input format is equals to so and so, output format is so and so, and rest all Hive will take care while creating a MapReduce for you. You have to just change the parameter of input format and output format. So I can read a sequence file. If I want to read the arrow file, again all I have to change is input and output format. Rest everything will remain same. So what I was talking yesterday and in the last classes, now does that make sense to everyone? I can precisely choose the file formats. I can precisely choose the compression. So compression also we can define over here in the table property only. We have to just tell compression also attribute. I'll tell you in the next two slides. And the rest everything will remain same for you. The MapReduce code will be automatically created for you. And how to get this arrow files created or sequence file created, that will make sense for you when I'm importing the data into the cluster with the help of Scoop. So while importing only, you can change the file format to different file format in which you want to keep your data. So while importing the data from the help of Scoop, I can just say store as sequence file. And from the Hive, I can just say input format as a sequence file so that Hive will read the data as a sequence file only. So I think I have some ping. So Padmani, as I told you, today's session was missed recording, and now I started recording up, but I did not start recording at the start of session, so that is missed. But the session is now recorded. So if I forget to click the record button over here, there's a reminder which is visible on your desktop also, which tells you that the session is getting recorded or not. So if by mistake I forgot it, please remind me. So now I'm in recording session, but prior to this was not recorded. Drop table, we have already did it, but the difference between external and enter table will be the same. Alter table, so you can alter the table. So once a metadata is created on a file, you can always alter it. Alter column, so here I am altering, I'm changing the column from HMS to hour minutes. So I'm renaming the column and changing the column type to int. I am changing the column after some other column. So guys, please remember, when you are altering a table, when you are doing any alteration on the table, high will never give you any error, any syntax error, or so it might give you syntax error, but any error related to the data. It's your responsibility if you are altering the data or if you are creating data the table on top of your files. It's your responsibility that the data is into that corresponding format. If the data is not into that corresponding format, uh, what is the metadata telling about? High will give an error while you are querying the data from the table, or it will just give you nulls. So if I alter the column data type to int over here, it's my responsibility to ensure that the data type of this column in the file is int only. It is not a string or something else. And here I am altering this column. I'm moving it after some other column. So it's my responsibility that the data in the file for this column is lying after this column. High will never give you an error. It will just read the data from the file corresponding to the metadata. So here I am again doing an altering on the table. So here I am saying replace column. So it will replace all the columns by these columns on my table. Alter table partition. So I'm changing the input file format for this table. I'm setting it to file format sequence file. So previously it might be text. Now I've changed to some other format. On the Hive, I have to just alter the table, set the file format to some new file format, and I will take care for the rest of the things for you. Renaming a table, alter table, rename it to some other table name. Alter table, set file format sequence file. I just shown you that example. Okay, so my data might change to some other format. So if I change this JSON, all I have to do is just change the Saturday property. Saturday is nothing, but I'm telling the Hive how to serialize and deserialize my data. So here I am saying the JSON property prop1 is equivalent to the value one, that is the column 1 of my table. Prop2 JSON property in the JSON is equivalent to value 2 in my table, and so on. So so if the JSON file is something like this, prop1 and the corresponding value, and this is the start of a JSON, prop2 and the corresponding value. And I've created a table something like this. Column 1 is value. So value 1 is the column name of type int, and val2 of type char. So here I'm saying this val1 is equivalent to this, and this val2 is equivalent to this in the table definition. The writing is not much readable, but if you are able to understand the concept, just ping me. Or let me show you in a JSON example only. JSON. So see, let's open this file first. Everyone understand what is JSON, right? Or is there someone who do not understand what is JSON? Okay, so see, this is the JSON file on which I want to create a table. Okay, cool. I hope everyone understands. It's pretty normal thing. It's pretty common also. So this is a file on which I want to create a table. So what I did is, I created a table and given the column names: field 1 string, field 2 int, field 3 string, field 4 double. So these column names are equivalent to your JSON key names. So here I do not have to define the Survey properties. But if these would have been different, I would have defined the Survey property similar to this. So this is what I'm changing in this alter table over here. So how to create a JSON table? All I have to do is just define that. I just use a JSON jar and the location, and the table will be created up. And this is how I can add a jar file to the Hive world. So this JSON jar is again openly available for us. I'll share this thing with you. Although this would be there in the shared drive. So add jar, create a table on top of this file, and your table is ready. So if I run this on the Hive console, select star from my table, and see the data from the table is there for you. And if I set the visible column names, so okay, so there are a lot of properties in the Hive as I told you, and how to look at them is set. So if you type set and press enter, this will show you all the different properties which are supported by Hive. So, but it's impossible for me to look or search for any property over here. So what I normally do is I go to the Unix console, type hive -e set. So this will return all the set properties over here to me. Why this guy is taking so much time? Now what I can do is type grep, and let's say I want to look at properties related to column. Or I think that would be related to header. Oh, let me check. So seek hive fetch column. So all the properties related to column are here for me. So I just wanted to print the header row names. That is, I think, header. So this is how you can search for the corresponding property which you are searching for. It just gave me 4, 5. Now I can just look at them. Yeah, print header. So by default it's false. If I set it to true, it will print the column names over there. So now if I do a select from this table, it will show you the column names and the data. So this is the JSON sorting, which I was telling you. Any questions? Okay, bucketing, again an interesting thing. Anyone understands or want to comment what is bucketing? No comments? Okay. But bucket will remain same. So Shelly just says too early, but the bucket. Okay. So let's say my data is there for employee table. And the data is partitioned based on, say, country. So different folders. and so on. So this is the top level folder employee, second level folder country equals US and country equals CA. Inside that say subpartition state is equals to AK and so on. These state might not be existing. I'm just printing some dummy values. And so on. So now if I have to run some queries like select from employee table where the country is equal to so and so, state equals to so and this will point directly to this partition and it will read the data. But if I have to do some join, so let's say I have another table called department, which do not have, so this employee table size might be say 5 petabytes because there will be a lot of employees for some big company. But the departments would be limited in the company. So let's say the department table size is some 1 GB or something like that. So now, but it's pretty frequent that I would be joining employee table and the department table. So what I can do is after partitioning, I can bucket my data also. And I can bucket this data based on department ID. Because I know that my employee and the department joins are pretty frequent. So what I'd say is, I bucket my data into 64 buckets based on a department. So employee table will have one column of department. So what will happen is there will be 64 files. If I say 64 buckets, the 64 files created inside each folder. And your data of department is equally divided into these 64 files. And how that is divided based on the hash value of your department. A department ID. So based on the hash value buckets, there will be 64 different files which will be created up, and each file will be catering a range of hash codes corresponding to a department ID. And if I bucket this department table also, so this will be only a single folder department, but there will be 64 files over here also. If I say 64 buckets, so when I'm joining these two tables, the file 1 of the department will be joined with the file 1 of state AK, and similarly for other files. Because I know that a file will be containing only a group of or only a subset of departments. So my joins are much faster if I bucket my data to the corresponding key on which my joins are much expected on the table. Does that make sense? Can you quickly say yes or no? What about others? Summarized? No, data is not summarized. I'm not doing any. I am not changing any of the data. I am just dividing the data into smaller files and doing a divide and rule kind of thing. Puneet, I'm not able to understand your part. How you are saying data will be summarized.
Okay. So Miraj, what I'm saying is that within state AK, so let's say there were 10,000 records. Okay. Let's assume that within AK there were 10,000 records. But grouping has been done on the basis of some column called department ID, and let's say there is only 64 distinct values of the department ID. So that 10,000 got grouped into...
No, 64, not 64 distinct values. So let's say department IDs range from 1 to 1 million. Okay. 64 buckets, the bucket 1 is scattering from say 1 to 5,000. 1 to 5,000. The bucket 2 is scattering from 5,000 to 1 to 10,000 and so on. So I'm sure that file 1, so this bucket 1 is nothing but file 1 which is created inside this folder, and similarly inside this folder. So when I'm joining, this file F1 will be joined with this file, with the file F1 of this folder. So I'm joining two smaller files. You can assume, you can think of how fast my MapReduce code will run. Because for joining, I have to loop the whole file to search for each record. I can't do no skip kind of thing. So joins are much faster if you bucket your data also based on your frequently running join conditions in your queries. Make sense or still make sense? Right. Okay. So Padmini, for you, what I'm saying is the bucketing really makes sense if you were to join two different tables on a given key, and that too frequently. So for that, what you do is you not only partition your data so that you achieve smaller subsets of the file, because you don't have to query the bigger files. You can further on subset divide your files into smaller groups, and where each file is capturing only a range of values. And how that range of values is decided based on the hash code of the key on which you have bucketed your data. And only the condition is if you are joining two different tables, your both the tables should be bucketed on the same key, and the number of buckets in each table should be a factor of the one. So if this table is bucketed on 64 buckets, this table should have been bucketed on 64 or 64 into n. Or it could be something like, or it could have been bucketed on 8 and then 64, so it's again 8 into 4. So basically they should be factor of each other. Otherwise the bucket will not work. If they are properly bucketed and the bucket key is same, you can easily join the two different tables.
Sure. Thank you so much.
Okay. Alter table. What I'm doing over it. Okay. So I hope now everyone remembers I told you also in the previous class. If you Hadoop is a cluster not created for smaller files, but for the bigger files. Basically, it does not encourages you to keep your data into smaller files. It rather encourages you to keep your data into one single bigger file. So, but in the previous example, what I was telling you is to divide the data into a format where you can overrule your basically run your queries faster up. But once your data is older, the smaller files you might want to get rid of those smaller files. So what you can do is you can use Hadoop archive that is called HAR. So HAR will not do anything. It will never compress your data. What all it do is it just create a single file out of your data. So it will not compress your data, it will not do anything, and once you unarchive this HAR file, your similar number of files will be there for you. So what you can do is you can alter or archive your older partitions with the help of HAR, so that your load on the name node is reduced. Name node is not managing your large number of file names. So although HAR you would practically not be using up because you are not doing so much load on the name node, but you can always HAR your older data. So the partition which are older, you can just use archive them with the help of archive command, and you can archive the older partitions. So if your partitions are created on the date, you can easily do that with the help of the corresponding dates. So you can also alter your partition by enabling not drop. By enabling not drop ensures that your partitions are never dropped. So you can also always draw. You can also you can drop a table. You can drop a partition also. But by enabling not drop, I will ensure that no one can drop a partition until unless you disable the not drop. Enable offline is similar to any other thing. So enable offline your data will never be touched by enable offline. Your data will remain there. But whenever you are running some query on the table, those partitions will never be included into your queries until unless explicitly stated. Or you can again disable the offline part. so that those partitions are included into your normal queries on those tables. Loading the data, I told you one of the way, insert into another table, loading from some other table, or you can load the data from your um, uh, files which are lying somewhere else. So here what I'm doing is load data local in path from this path and overwrite into table so and so, partition by so and so. So interesting command. Load data local in path so and so. So the data which is lying at this location will be overwritten into the table employees on the partition US subpartition Canada. So the data which is lying at the Canada, not Canada, CA is California, I think. Inside the state California, all the data would be deleted up, and the data at this location in the file system would be inserted into this partition. So load data local in path override. If I would have used, instead of override as a keyword here, I've used insert into. In that case, the data would be appended to this partition. But if I've used the keyword override, the data would be overwritten. So there's a little difference between load data local and without local. So load data local copies the local data to the final location in the distributed file system, while load data without local as a keyword in path move the data from one given SDFS location to the final location. Local so when I'm giving local as a keyword over here, this path which I'm giving is a local path of my Unix world. But if I'm not giving this local as a keyword, what this path I'm giving is the path of a SDFS word only. So this is the difference between load data with local and without local. And with override and without override, rather than override, I can use insert into. So insert into will append the data, override will override the data. So here I'm talking about that thing again, inserting. So here what I'm doing is I'm selecting from some other table and inserting into this table, and both the tables are partitioned. So I'm selecting from some partition of this table and I'm putting this data into this table of the corresponding partition. But I can also say into the partition column names and just select the data. So in this case, Hive will figure out to which partition my data should go. The way I did for a stock table, I did not give the partition a static partition. So this is a dynamic partitioning. So the dynamic partitioning is by default disabled into Hive, and that is a set command which I triggered over there in that while I use that partition example which I ran. So I disabled the default static partitioning to false, and I enabled the dynamic partitioning by setting that parameter. So here you can see I did not give the country and the state value like I gave over here. So this is an example of dynamic partitioning. Here Hive will decide based on the data which is selected from the below query to which partition the data should go into the employees table. And this is an example of semi-dynamic partitioning. So this is basically a mix of dynamic and static partitioning. Here the country is static, but the states are based on the data selected from the subquery. So these are different ways how you can use the power of Hive to partition your data. And similarly, you can bucket your data also. So this is the parameter which I set over there to enable the mode of dynamic partitioning. So insert, override, local, I just told you. All these things I just told you. Okay, so here it's pretty common. So one more thing. The VM which I've shared with you people is containing Hive version 0.13 or I think 0.12. But at Hive version 0.14 and greater on, you can do a So if till now, if you remember, you might be running queries like select from table A, comma B, comma C, where X, Y, Z. So from table A, comma B, comma C would not work in Hive version less than 0.1.4. So in this the version which I've shared with you, you have to use inner joins or outer joins. The from A, comma B, comma C will not work for you. So please ensure that if you want to use from A, comma B, comma C, you have to use Hive version greater than 0.13, that is 0.14 and greater on. If you want that VM, do let me know. That VM is around 5 GB, and please ensure that the RAM on your laptop is 8 plus GB. Then only you'll be able to run it, because that will eat nothing less than 6-7 GB RAM on your PC. So if you have that thing on your PC, do let me know. I'll share that version of the VM also with you. So it's a simple nested command. So similar to your MySQL word, you can also run nested queries over here. So here I've created a nested table E, which is an output of this query, and I'm using this table in the next select query. Although I've written it a pretty complex way from this table, you would have written in a similar way. Select from table, and you have given this. You would have written something like this also. This select would have been came over here, and in this table, similar to how you do in a MySQL word also. This is a little complex way to write it. Case statement, select from this case where this, then this, and this. Normal syntax. Wherever you want me to, go in detail, do let me know. I'm just assuming all these things are much familiar to you people. So group by, having, joins. This is what I was talking about. Select from table, join on next table, on this condition, where on some clause. So you have to use joins only. The from A, comma B, comma C will not work. So what I'm saying is, where's my text pad? Select star from A, comma B, where A dot ID is equals to B dot ID. This will not work for you. What you have to write is select star from A, join or inner join B on A dot ID is equals to B dot ID. So this will work in the version of Hive which you have. This will not work. So now you can optimize or give hints the way you give an Oracle or any other relational database to Hive also. So these are few common things, but there is an extensive list of these things. I'm not going into those details. So here what I'm doing is when I'm joining two tables, Hive assumes your first table is small. If that is not there, your code might run slower. So if your first table not small, you can give a hint to Hive like this, streamable, or use your first table as a smaller table as compared to the next table. So it will load your smaller table into memory, and it will parse the bigger table one by one. So it will read the records of a bigger table one by one and load the small table into memory. And this is how it will be doing a join on two tables. So it's assumed the first table which is given in your query is faster. Or you can use the hint, streamable, which table to be streamed in the memory and which table need to be iterated from the disk. Left join, right outer join. Anyone want me to explain what is right and left outer join?
So with a left outer join, it includes what intersects and everything on the left side, and right inner join, it will include the intersection and everything on the right side.
Yes, on the right hand side, and those would become null. So if nothing is there on the left side, corresponding to the right side. If you're using. functions. So you can just say show functions over here. This will tell you all the input functions like show tables, all the input functions in the Hive. And you just think of most of the functions will be there corresponding to a string, corresponding to tables, mathematical functions corresponding to a string, corresponding to your ltrim, rtrim, sum, all those things. Year, date related functions, XML related functions, or you can create your own functions also. So how to create your own functions? That is called user defined functions. So you can write your Java code. I'll show you that part. Or you can create your functions in any other language also, and not other than Java. But if you are using Java to create function, you have to just extend one class and create a jar out of it. Add that jar so this is how you create a UDF. So you just extend UDF, that is a class of Hive, and override a function called evaluate. Do whatever processing you want to do over there, and return the output, and create a jar out of it. After you create a jar out of it, just add that jar in the Hive. Create a function. So I created a function named hello world as this class name. So this is a class name which I created over here. That is simple UDF example. So I've given the class name over here, and this will always call the function called evaluate in this class. And now I can just say hello world and the processing which I want, the data on which I want to do the processing, and I can this will trigger my user defined function. Similarly, you can create a function in any other language also. So you can add those jars, and you can just add the function. So it's not mandatory to write a UDF in Java. You can create it in any other streaming languages also. So if I show you an example, so the code is there over there. Let me show you one of the code. And by the time Eclipse is opening up, let me show you it over here also. Am I not audible to anyone, or is just Puneet who can't hear me?
I can hear you.
Puneet, I think there's some problem at your end. So yeah, that's the reason I am not using Wi-Fi today. I'm using the wired cable today, because yesterday there was a trouble with the problem, the voice. So there's a problem with your end only today. So so here's okay. I have not shown you this sequence file and the cluster table also. By the time that is running up, let me show you these things. So see, I am reading the data in the format of sequence file. And if let's see, there's some sequence file lying in the cluster, I can read that sequence file. So this is a data in sequence file. We can't read it. So if we create a table on top of this by just giving this thing, so select star from sequence file. Now the sequence file formatter will be used for you, and the data is ready. See, and cat, let me, so this is an example of bucket. So I said cluster my data into 4 buckets based on the column called symbol. So let's create this table. Okay, now what I'm doing is I am just inserting the data into this table from some other table. Rest all thing Hive will do. It will cluster our data, similar to the partition. So I'm selecting the data from stocks. One of the column of stocks table that was symbol, that was stock name. I have clustered this table on that symbol. Rest all columns are there. So there will be files created, 4 files created in my directory. Each file will be catering a range of stock names. So this is running up. I'll show you the UDF also in a minute. This is the most quiet class I have ever seen. So I've taken batches from long, and this is the most quiet batch I have ever seen. People just kill me with the questions in the MapReduce part and the basic Hadoop and in the Hive also. But I have not even heard a single question in the whole session today. So see, it's
So I think
good.
that for me, I mean, I have to play a little bit with Hive to really understand it.
Yes. So
So
after this session, I'll give you the problem statement, and I'm not sure whether I shared with you the MapReduce problem statement or not. I'll share that thing also with you. But Hive, I'll just share with you. So let's go to this. What was the path of this folder? Cluster table. So let's look at this cluster table. Cluster table. Cluster table. So there was some previous data also. That's the reason you can see copy. This is created by Hive. It's just some previous data is there. So 4 files, and each file will be having a range of values. So this has only Reliance. This says SBI. So we don't have much, distinct values. This is sale and bell. This is nothing. Okay, so the Eclipse is open. Let me show you the UDF. UDF. So here I am extending that UDF class, and what I'm trying to do over here is, in this example, there is nothing like foreign keys or the primary keys kind of concept over here. You have to forget all those things. But I required something similar to that, that is a primary key or a unique key for my table, which I wanted to refer as a foreign key in some other table in our data warehouse, which I was creating for eBay. So what I did is I created a program where what I'm doing is I'm getting, so I used less than nano time, but that thing failed for me. I used a micro time, that thing failed for me. So I explicitly used nano over here. And after nano, what I'm doing is, so I'm generating a nano time. After that, I am getting the IP address of the node where this program is getting triggered, because each node would be running the Hive program. So each node would be having separate IP address. So I am getting the IP address of the node, and at the end, I am adding a random mathematical number of 3 or 5 digits, I think. I am combining all those three things and creating a unique value for each row inserted into my table. And I was using that as a unique value for each row. With a microsecond, I got duplicate records, so I have to use nano explicitly with the random number as well as the IP address of the node. So this is one of the UDF which I created. Now to use it, all I have to do is just create a jar, add that jar, similar to what I've showed over here. Add that jar and create a function. And to create a function, all I have to do is just give the fully qualified class name of this Java class. So this name dot key incremental, and I can just give any function name to this, function, and I can call that. Indexes, believe me, trust me, although you can create indexes in Hive, but overhead of maintaining these indexes is too high, and the real benefit which you get while using the indexes is much lesser as compared to overhead of creating these indexes and maintaining them. So, but you can create the index by, so this is a table on which you can just create an index by create index on this table by giving the class name. Also, there are different index handlers in Hive. So this is the one which I'm using over here. Default rebuild means that the index will be created when the user will give a command. And similar to the tables, you can also partition your index. So, but I suggest you never to use indexes in Hive. That's my personal experience. Any questions, anything on this part?
I just think it's going to take some time playing with it.
Yes. So I'm just now sharing, problem statement with all of you. Just try that out. That will be reaching your Gmail. Just try that out. We have 15-20 minutes. If you can extend for 5-10 minutes, 5-10 more minutes. Just try it on your laptops and try to run that, and that will really gives you hands-on. I'm also sharing the PPT right away with you on your Google Drives. So if you people have time, you can just try that right now, or if you want to try it later on, it's your you can do that also. So, but just give me a minute. I'm sharing this thing. So I've shared a Hive exercise with you people. That there's an email in your Gmail right now. Just check that and you can just look at the Hive exercise. And I'm also sharing this PPT because without this PPT it will be difficult to you for you people to run that Hive exercise, right? So I've shared the PPT into the PPT drive, and I've also shared one problem statement. You people can just open the problem statement and look into that part. Everyone got it right? Is there anyone who has not got it?
I've got it.
Okay.
I too got it.
Okay. So just have a look at this and try this out. And if you people are okay with extending a little bit, I can help you out with any of the problem which you're facing while running this program. Or if you want to do it in the next week, we can do that also. No, nothing to be continued, Padmini. So
Okay. Thanks, Miraj. I'll just try to install and then I'll start looking into the sessions.
Okay, sure. So people are saying they want to try. Sure. So people are saying they want to try it later on. So try it later on, and let's discuss it in the next class. Try this exercise. This will give you a real hands-on Hive. If you understand Hive and able to run it, you can achieve more than 50 to 60% in your Hadoop world.
Oh, sure.
Okay, then, yeah. Thanks everyone for your time. And if you have any questions, any queries, just drop me an email.
Okay, thank you. Have a nice day.
Thank you. Same to you. Have a nice day. Bye-bye.